The idea of the solar system was first proposed by the Polish astronomer Nicolaus Copernicus in 1543. The solar system was formed 4.6 billion years ago from the gravitational collapse of a giant interstellar molecular cloud. The first exploration of the solar system was conducted by telescope, when astronomers first began to map those objects too faint to be seen with the naked eye. Galileo was the first to discover physical details about the individual bodies of the solar system. In 2007, researchers at the University of California, Davis determined that our solar system was fully formed at 4.568 billion years ago. The scientific approach to the origin of the solar system became possible after the publication of Isaac Newton's laws of motion and gravitation in 1687. Emanuel Swedenborg proposed. Launched 16 days after its twin Voyager 2, Voyager 1 has been operating for 46 years, 1 month and 6 days as of October 12, 2023, UTC. Voyager 1 has explored the Jovian and Saturnian systems, discovering new moons, active volcanoes, and a wealth of data about the outer solar system. It has also discovered new rings and moons around Jupiter and Saturn, respectively. On August 25, 2012, Voyager 1 entered interstellar space after detecting a dip in the levels of charged particles that originate from inside our heliosphere, green, and rise in the levels of cosmic rays, charged particles that originate from stars other than our Sun, orange. It is currently the most distant human-made object in existence. Over the next few hours, Voyager 2 flew within 50,600 miles, 81,433 kilometers, of Uranus's cloud tops, collecting data that revealed 2 new rings, 11 new moons and temperatures below -353 degrees Fahrenheit, -214 degrees Celsius. The dataset is still the only up-close measurements have ever been made of the planet. Voyager 2 is a spacecraft launched from Earth in 1977. It is currently traveling more than 11.6 billion miles, 18.8 billion kilometers, from Earth. According to a recent report, NASA has re-established contact with Voyager 2 and the spacecraft is alive and responding to commands broadcast from Earth. It is currently transmitting scientific data at about 160 bits per second. The spacecraft is beyond the heliopause, or boundary region, where the Sun's influence ends and the interstellar medium begins. Voyager 2 entered interstellar space on November 5, 2018, and scientists hope to learn more about this region. As of August 4, 2023, NASA has reported that Voyager 2 is currently unable to receive commands or transmit data back to Earth. Voyager 2 is located more than 12.3 billion miles, 19.9 billion kilometers, from Earth. The last time Voyager 2 transmitted scientific data, friction slowed it down enough, and finally being lowered gently to the red dirt on cables by a rocket-powered sky crane. Once the rover reached Mars' atmosphere, it shed all its solar panels, shields, and fuel tanks that were used to get it from Earth to its final destination. The landing site for Perseverance was Jezero Crater, which once hosted a deep and potentially long-lived lake. The rover autonomously timed its movements so that it would alight within a roughly 4-mile-wide landing ellipse in Mars's Jezero Crater. The Atlas V-541 rocket launch vehicle, designed and built by Lockheed Martin for the United States Air Force, is equipped with a Telemetry and Command Data Unit, TCDU, which is responsible for communicating with the ground station. The TCDU is a digital communication system that receives and transmits data between the rocket and the ground station. The TCDU is capable of transmitting data in both directions, allowing the ground station to send commands to the rocket and receive telemetry data from it. The TCDU uses AS-band frequency for communication, which is a type of radio frequency used for long-range communication. A spacecraft command and data handling (C&DH) system handles all data sent and received by the spacecraft, including science data and spacecraft or payload operations. The system is connected to RF transmitter and receiver units that are the sole point of passage for data entering or leaving the spacecraft. The Curiosity rover was sent to Mars through a daring landing sequence. The spacecraft was launched by an Atlas V-541 and delivered into a 103 times 201-mile orbit around Earth at a 35.5-degree inclination. The spacecraft then fired rockets to allow it to hover while a tether lowered Curiosity to the surface. The landing sequence was extremely complicated due to Curiosity's weight, and NASA dubbed it 7 Minutes of Terror. The rover was launched on July 30, 2020, at 4:50 a.m. Pacific Daylight Saving Time, 7:50 a.m. Eastern Daylight Saving Time, from Launch Complex 41 at Cape Canaveral Air Force Station, Florida. The launch vehicle provides the velocity needed by a spacecraft to escape Earth's gravity and set it on its course for Mars. Once the spacecraft reaches Mars, it enters the Martian atmosphere and deploys a supersonic parachute after friction slows it down enough. The spacecraft is then lowered gently to the red dirt on cables by a rocket-powered sky crane. The rover will hunt for signs of ancient life, collect and cache samples for future return to Earth, and help demonstrate a variety of new exploration technologies, among other tasks. The time it takes to travel from Earth to Mars will be determined by the speed of the launch. Liquid hydrogen is essential in the US space program because it powers satellites. The amount of fuel required to power a rocket to Mars depends on the type of rocket and the mission design. According to one estimate, approximately 15,000 pounds, 7 metric tons, of rocket fuel and 25,000 pounds, 25 metric tons, of oxygen would be required to return 4 astronauts from the Martian surface. Another estimate suggests that the rocket would need hundreds of thousands of gallons of liquid hydrogen, liquid oxygen, and kerosene fuel to launch from Earth and reach Mars. It's worth noting that NASA is currently working on developing technology that would allow them to create rocket fuel on Mars using local resources such as carbon dioxide and water. This could potentially reduce the amount of fuel needed for future missions. NASA has sent several rovers to Mars using rockets. For instance, the Mars 2020 Perseverance rover was launched on a 2-stage Atlas V541 launch vehicle, provided by United Launch Alliance, a joint venture of Boeing Company and Lockheed Martin Corp. The launch vehicle provides the velocity needed by a spacecraft to escape Earth's gravity and set it on its course for Mars. Once the spacecraft reaches Mars, it enters the Martian atmosphere and deploys a supersonic parachute after friction slows it down enough. The spacecraft is then lowered gently to the red dirt on cables by a rocket-powered sky crane. The rover will hunt for signs of ancient life, collect and cache samples for future return to Earth, and help demonstrate a variety of new exploration technologies, among other tasks. The Mars Science Laboratory spacecraft, which carried the Curiosity rover, arrived at Mars through a new landing method that tested technological innovations. The spacecraft descended on a parachute, then during the final seconds before landing, the landing system fired rockets to allow it to hover while a tether lowered Curiosity to the surface. The rover traveled through space enclosed in a protective aeroshell consisting of 2 parts, a conical back shell and a heat shield. The aeroshell was connected to a cruise stage that fired thrusters to keep the spacecraft on course, ensuring it arrived at Mars in the right place for landing. Please note that the Mars rover Perseverance was delivered to Mars using a different method than Curiosity. It was launched on July 30, 2020, and arrived at Mars on February 18, 2021. The rover was delivered using a sky crane technique that was also used by its predecessor, the Curiosity rover. During this process, the rover was lowered onto the Martian surface by cables from a hovering descent stage. Curiosity uses its high-gain antenna to receive commands for the mission team back on Earth. The high-gain antenna can send a beam of information in a specific direction, and it is steerable, so the antenna can move to point itself directly to any antenna on Earth. The NASA Deep Space Network, DSN, is an international network of antennas that provide the communication links between the scientists and engineers on Earth to the missions in space and on Mars. The DSN consists of 3 deep space communications facilities placed approximately 120 degrees apart around the world, at Goldstone, in California's Mojave Desert, near Madrid, Spain, and near Canberra, Australia. This strategic placement permits constant observation of spacecraft as the Earth rotates on its own axis. The DSN antennas are extremely large, 34 meters, about 37 yards, and 70 meters, about 76 yards. These enormous antennas enable humans to reach out to spacecraft millions of miles away. The larger the antenna, the stronger the signal and greater the amount of information the antenna can send and receive. The Mars Science Laboratory, while in its cruise stage configuration, communicated through low and medium gain antennas. While Curiosity is roving on the planet, it is communicating with the Mars Reconnaissance Orbiter via its UHF antenna and to the DSN on Earth by way of its high-gain antenna. The first thing that the Perseverance rover did upon landing on Mars was to take its first image of the dusty Martian surface. The image was taken mere moments after the rover touched down on February 18, 2021, following a 300 million-mile journey that took 7 months. The landing process was followed around the world and was particularly memorable because of the spectacular video taken from both the rover and its descent stage showing the touchdown onto the red planet. When the rover landed on the red planet, its entry, descent, and landing hardware flew off to crash a safe distance away, scattering debris across the Martian surface. The Mars 2020 Perseverance rover is a robotic vehicle that was launched by NASA on July 30, 2020, and landed on Mars on February 18, 2021, in the Jezero crater. The rover is part of NASA's Mars exploration program and is designed to explore the red planet for signs of ancient microbial life. Perseverance is equipped with a suite of scientific instruments that will help it achieve its mission objectives. These include a drill that can collect rock and soil samples, a camera system that can capture high-resolution images, and a weather station that can measure temperature, wind speed, and other atmospheric conditions. One of the most exciting aspects of the Perseverance mission is the collection of rock and soil samples from Mars. These samples will be stored in sealed tubes and eventually returned to Earth by a future mission. Scientists hope that these samples will provide valuable insights into the geological history of Mars and help us better understand the potential for life on other planets. In addition to its scientific objectives, Perseverance also carries a small helicopter called Ingenuity. This is the first time that a helicopter has been flown on another planet, and it represents a significant technological achievement. Overall, the Perseverance rover is an important step forward in our understanding of Mars and our search for extraterrestrial life. The Curiosity rover landed on Mars using a new and daring landing process called the 7 Minutes of Terror. The spacecraft descended on a parachute, then during the final seconds before landing, the landing system fired rockets to allow it to hover while a tether lowered Curiosity to the surface. The rover landed on its wheels, the tether was cut, and the landing system flew off to crash land a safe distance away. The guided entry within the aeroshell was helped by small attitude control jets that narrowed the landing ellipse for MSL to an area of about 12 times 4 miles, 20 times 7 kilometers. The first thing Curiosity did upon landing was to send a low-resolution thumbnail image of its surroundings back to Earth. This image was taken by the Mars Descent Imager, MARDI, camera mounted on the rover's underside and showed the rover's shadow and the Martian horizon. The image confirmed that Curiosity had landed safely and was ready to begin its mission. NASA's first ever Mars rover, named Sojourner, successfully landed on Mars on July 4, 1997. It arrived aboard the Mars Pathfinder. Sojourner was a tiny remote-controlled rover that traveled a few meters around the landing site, exploring the conditions and sampling rocks around it. This was the first successful landing of a rover on Mars. The first thing Sojourner did upon landing was to take a panoramic image of its surroundings using its front and rear cameras. The image was then transmitted back to Earth, marking the first time a rover had sent back images from another planet. After that, Sojourner began its scientific mission by analyzing rocks and soil samples in the vicinity of its landing site. The rover, named Sojourner, landed in July 1997 at Ares Vallis using an airbag to cushion the fall. This first rover was equipped with an X-ray spectrometer and several cameras. The cameras showed images of rounded pebbles and cobbles upon landing, evidence for the groundbreaking discovery that there was likely once stable liquid water on Mars. The Voyager 1 and 2 spacecraft were launched in 1977 by NASA to explore the outer planets of our solar system. The primary mission was to study Jupiter and Saturn, but the mission was later extended to Uranus and Neptune. The Voyager Interstellar Mission, VIM, is currently exploring the outermost edge of the Sun's domain and beyond. The spacecraft communicate with Earth using the Deep Space Network, DSN, which is a collection of big radio antennas that receive information and pictures from the spacecraft. The antennas also receive details about where the spacecraft are and how they are doing. NASA uses the DSN to send lists of instructions to the spacecraft. The radio communication system of Voyager 1 was designed to be used up to and beyond the limits of the solar system. The communication system includes a 3.7-meter, 12 feet, diameter high-gain Cassegrain antenna to send and receive radio waves via the 3 Deep Space Network stations on Earth. In summary, while the Voyager missions did not directly inspire a mission to Mars, they played a crucial role in advancing our understanding of space exploration and developing new technologies that will be essential for future missions to Mars. NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California, managed the 2 spacecraft on their missions to explore the outer planets. Taking advantage of a rare planetary alignment to use the gravity of one planet to redirect the spacecraft to the next, The Voyagers plan to use Jupiter's gravity to send them on to explore Saturn and its large moon Titan. They carried sophisticated instruments to conduct their in-depth explorations of the giant planets. Both spacecraft continue to return data as they make their way out of our solar system and enter interstellar space. While the Voyager missions did not directly inspire a mission to Mars, they did provide valuable insights into the outer planets and their moons. The data collected by the Voyager spacecrafts helped scientists better understand the composition and behavior of these planets, which in turn helped them develop new technologies and techniques for space exploration. The Voyager missions also demonstrated the feasibility of long-duration spaceflight, which is essential for human missions to Mars. The spacecraft's ability to operate for over 40 years in deep space has provided valuable lessons for designing spacecrafts that can withstand the harsh conditions of interplanetary space.
By the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth. And a landing on Mars will follow, and I expect to be around to see it.
As of 2023, scientists have made significant progress in understanding Mars. The latest rover, Perseverance, has been busy roving for over 2 years and has been bristling with science instruments. It has cameras of multiple kinds used both for general imagery and spectral analysis that can identify minerals. That latter function is supplemented by an additional X-ray instrument. Perseverance also has a ground-penetrating radar instrument that can reveal layering hidden below the surface. More invasively, there is a drill on the end of the rover's robotic arm. This is used to grind clean, what geologists call fresh spots for analysis, but it can also core out small cylindrical rock samples, hopefully to be retrieved and returned to Earth by a future mission. Perseverance's mission set down in Jezero crater, which was chosen because rocks resembling a river delta are draped over its rim, indicating that flowing water might have met a lake here in the past. It's the perfect environment to study the history of water on Mars and the possibility of life associated with it. In addition, scientists have made the most precise measurements ever of Mars' rotation, for the first time detecting how the planet wobbles due to the sloshing of its molten metal core. Finally, NASA's Perseverance rover may already have evidence of ancient Martian life. In January 2023, Perseverance deposited 10 tubes on the surface of Mars. Each contains a sample of Martian rock that was carefully selected for its potential to clarify chapters of the planet's still murky history. Astronomers determined that the planet's spin is increasing by about 4 milliarcseconds per year, or shortening the length of a Martian day by a fraction of a millisecond per year. A Martian day lasts about 40 minutes longer than a day on Earth. The interplanetary internet computers are designed to operate at interplanetary network distances, where traditional protocols such as the Internet Protocol break down. The vast distances between planets and their constant motion impose long and variable delays on communications, making it difficult for traditional protocol stacks to function properly. To address these constraints, a delay, disruption-tolerant network, DTN, is implemented. The interplanetary communication is greatly delayed by interplanetary distances, so a new set of protocols and technologies that are tolerant to large delays and errors are required. The routes of the planet-to-planet communication are planned and scheduled rather than being opportunistic. The interplanetary internet design must address these challenges to operate successfully and achieve good communication with other planets. It also must use the few available resources efficiently in the system. In summary, the interplanetary internet is designed to be tolerant to delays and errors that arise from the vast distances between planets. However, it is still in its early stages of development, and there are many challenges that need to be addressed before it can be considered stable. Preparing for a mission to Mars requires astronauts to be in excellent physical condition. The journey to Mars is long and arduous, and the astronauts will be exposed to high levels of radiation, microgravity, and other hazards. Therefore, they must undergo rigorous physical training to prepare their bodies for the journey. According to an article on Science News Explores, scientists are working on making a human mission to Mars a reality. They are developing ways to make astronauts more Earth-independent than on missions closer to home one. The article also mentions that astronauts headed to Mars will have to take along almost everything they'll need. They might be able to harvest some raw materials from the red planet. But afterward they'll need some way to use them. 1. Astronauts will need to maintain their physical fitness during the journey and after landing on Mars. According to New Atlas, the current method of preventing muscle and bone loss and the loss of general fitness is exercise. Astronauts often use themselves as guinea pigs to test the effects of space on the body. The results can be used to prepare for long-duration space flights, like a mission to Mars in the future. The complex process of preparing astronauts for their space missions before, during, and after the flight. This includes medical tests, physical training, extravehicular activity, EVA, training, procedure training, rehabilitation process, as well as training on experiments they will accomplish during their stay in space. In summary, astronauts preparing for a mission to Mars must undergo rigorous physical training and maintain their physical fitness during the journey and after landing on Mars. They must also be prepared for long-duration space flights and be able to perform various tasks while in space. NASA monitors its astronauts in orbit 24/7, aiming both to learn new information about how human bodies adapt to microgravity as well as to keep track of their health day to day. To monitor the vital signs of astronauts in real time, NASA uses a portable diagnostic device that streams real-time vital signs to the astronauts and NASA's medical team on Earth. The device is equipped with a sensor that is affixed to the chest and a nanostrip that collects a single biological sample, which could be blood, saliva or urine. The nanostrip is then inserted into the device, which streams real-time vital signs to the astronauts and NASA's medical team on Earth. Another wearable technology designed to fit into an astronaut's daily routine aboard the International Space Station, ISS, while monitoring and recording vital signs is the biomonitor. The biomonitor is an all-in-one wireless garment that records vital sign data such as pulse and electrical activity of the heart, blood pressure, breathing rate and volume, skin temperature, blood oxygen saturation, and physical activity levels. The smart shirt can also be worn during sleep and exercise. The system is designed to easily send information to the ground, where scientists can monitor the astronauts' health around the clock as they orbit the planet. NASA has developed several methods to monitor astronauts' health in real time while they are in space. Astronauts' vital signs are monitored using a sensor affixed to the chest, which streams the data to the astronauts and NASA's medical team on Earth. 1. Spacelabs Healthcare has developed a real-time system for monitoring astronauts' vital signs while in orbit, including a telemetry system to simultaneously transmit the data back to Earth. 1. Astronauts use several medical devices including electrocardiographs, blood pressure cuffs, fingertip oxygen saturation monitors, and ankle bracelet activity sensors to participate in health experiments. NASA has also tested portable diagnostic devices that can monitor astronauts' health in real time. The device consists of a sensor affixed to the chest that streams real-time vital signs to the astronauts and NASA's medical team on Earth. The astronaut collects a single biological sample, which could be blood, saliva or urine, on a nanostrip. After this, the nanostrip is inserted into the device. In addition, NASA is developing artificial intelligence systems that can monitor astronaut health in space. The system is based on sophisticated algorithms and machine learning developed by NASA and is able to learn about the patient through data from wearable and wireless devices, adding to medical records. The cloud-based program employs off-the-shelf health and fitness monitoring devices to collect important health metrics. It then saves, analyzes, reports on, and distributes information to the patient and the entire medical team. There are many space agencies and private spaceflight companies that have plans to send humans to Mars, possibly even within the next few decades. NASA has ambitious plans to land astronauts on Mars by 2040. The 2017 NASA astronaut class includes 5 women and 7 men, and additional recruits came from other agencies that year, such as the European Space Agency and the Canadian Space Agency. The UAE has also sent 2 crew members to train at Johnson Space Center with the new 2021 class. As of October 2023, there is no official announcement on who will be the first astronaut to Mars. However, NASA has announced that the first human to walk on Mars will be Christina Koch, an American engineer and astronaut. NASA's Artemis program aims to establish a long-term presence on the Moon and use what they learned to send the first astronauts to Mars. SpaceX's CEO Elon Musk has expressed his confidence in launching people towards Mars in 2026. Christina Koch is an American astronaut who was selected by NASA in 2013. She completed astronaut candidate training in 2015 and most recently served as a flight engineer on the International Space Station for Expedition 59, 60, and 61. Koch set a record for the longest single spaceflight by a woman with a total of 328 days in space. Koch is a native of Grand Rapids, Michigan, grew up in Jacksonville, North Carolina, and resided in Livingston, Montana before relocating to Houston, Texas to join the astronaut corps. She enjoys backpacking, rock climbing, paddling, surfing, running, yoga, community service, photography and travel. Koch attended North Carolina State University in Raleigh, North Carolina, where she earned a Bachelor of Science in Electrical Engineering, 2001, a Bachelor of Science in Physics and a Master of Science in Electrical Engineering, 2002. She received an honorary PhD from North Carolina State University in 2020. Christina Hammock Koch, born January 29, 1979, is an American engineer and NASA astronaut of the class of 2013. She received Bachelor of Science degrees in Electrical Engineering and Physics and a Master of Science in Electrical Engineering at North Carolina State University. She also did advanced study while working at the Goddard Space Flight Center. Just before becoming an astronaut, she served at the National Oceanic and Atmospheric Administration as Station Chief for American Samoa. According to a study funded by NASA, astronauts may be put into a state of deep sleep or torpor for long journeys such as the one to Mars. This would involve reducing their basic bodily functions to a bare minimum and administering feeding intravenously. The company SpaceWorks has proposed Mars transports and studies of induced torpor for their passengers. The crew could sleep in shifts, with each astronaut in torpor for about 2 weeks and then conscious for 2 days, ensuring that one crew member is always awake during the mission. Scientists suggest building soft shell pods with fine-tuned settings for sweet hibernation, a quiet environment with low light, low temperature, less than 10 degrees Celsius, and high humidity. The astronauts would move very little but would not be restrained and would wear clothing that avoids overheating. It is important to note that hibernation on a year-long trip to Mars would not just prevent boredom in a tiny space capsule. It would also save mission cost, as the hibernating crew members wouldn't need to eat or drink and would even require far less oxygen than those awake. Supplies and hardware will also be sent ahead of the crew, including a crew ascent vehicle for the astronauts to eventually make their way off the red planet's surface. NASA has identified several types of supplies that will be sent ahead of the crew to Mars, including a habitat-like spacecraft used to ferry astronauts to Mars using a hybrid chemical-electrical propulsion rocket stage, and a crew ascent vehicle for the astronauts to eventually make their way off the red planet's surface. In addition, NASA will send supplies and hardware ahead of the crew. These supplies may include food, water, oxygen, clothing, medicines, and energy. It is also worth noting that microbes may play an essential role in human survival on Mars. Many of the needs of a manned mission to Mars can be met with living organisms. NASA is currently developing a propulsion system for future Mars missions. One of the 3 prototype engines that could be selected by NASA to power future manned missions to Mars is the X-3 ion thruster. The X-3 is a Hall effect thruster, which is a type of ion thruster in which the propellant, most commonly xenon, is accelerated by electric and magnetic fields. Such thrusters are safer and more fuel efficient than engines used in traditional chemical rockets. The X-3 features the largest throttling capability of any Hall thruster to date, 7 firing configurations, and power levels ranging from 2 to 200 kilowatts. It could be the best choice to become a fundamental component of spacecraft carrying astronauts beyond Earth. NASA has not yet announced the other 2 engine prototypes that could be selected for future Mars missions. However, NASA has selected Lockheed Martin to build the Mars Ascent Vehicle, MAV, a relatively small rocket meant to propel Perseverance's samples into orbit. SpaceX is also working on developing a rocket that could take humans to Mars. The company's first crewed Mars mission could launch as early as 2024. However, it is unclear which engine prototype SpaceX will use for this mission. As for how humans will take off from Mars, National Geographic reports that when it comes time to take off from the Martian surface, the MAV will need 33 tons of propellant to break free of the red planet's gravity, push through its atmosphere, and safely ferry the astronauts and their scientific cargo into orbit, where they can rendezvous and dock with their Earth return vehicle. While robotic explorers have studied Mars for more than 40 years, NASA's path for the human exploration of Mars may begin in low Earth orbit aboard the International Space Station. SpaceX will probably launch its Starship spacecraft from its launch site at Boca Chica, Texas. NASA's Space Launch System, SLS, rocket is also being developed for future missions to Mars. The first astronauts to Mars will likely experience a range of emotions, including excitement, anticipation, and perhaps some fear. The journey to Mars is long and arduous, and the astronauts will have to contend with deep space radiation, the effects of microgravity, and the stress of confinement and isolation, all at the same time and for a long, continuous stretch. However, it's worth noting that astronauts are highly trained professionals who undergo rigorous physical and psychological testing before being selected for space missions. They are trained to handle high-stress situations and are equipped with the necessary tools and knowledge to deal with any challenges that may arise. In summary, while the first astronauts to Mars may experience some fear, they are well prepared for the journey ahead. NASA has provided a few tantalizing details describing its first crewed mission to Mars, which is expected to take place at some point in the 2030s. According to former NASA chief Jim Bridenstine, NASA hopes to launch humans to Mars in the next decade or in the early 2040s. The space industry has to think up solutions to some of the biggest challenges facing the first humans to reach Mars. Gravity, for example, will be an issue, with humans facing tough conditions as they acclimatize to gravity on Mars after months in microgravity. Mars has roughly one-third the gravity of Earth, but astronauts' muscles will have degraded to the point they may struggle to walk when they first reach the planet. We want to maximize the science, so we allow him to drive around before they become conditioned enough to get in the spacesuits, and walk and maximize that science in 30 days. The cruise phase begins after the spacecraft separates from the rocket, soon after launch. The spacecraft departs Earth at a speed of about 24,600 miles per hour, about 39,600 kilometers per hour. The trip to Mars will take about 7 months and about 300 million miles, 480 million kilometers. According to NASA, the duration of a human mission to Mars is estimated to be around 7 months on average, with some opportunities to adjust the flight path. However, the exact time it takes to fly to Mars depends on several factors, such as the position of the planets, the technology, and the type of mission. Past missions have taken between 128 days and 333 days to reach Mars. Please note that the duration of a human mission to Mars is subject to change based on various factors such as technological advancements, funding, and other unforeseen circumstances. Piloting humans to Mars is a complex and challenging task that requires extensive planning, preparation, and resources. The journey to Mars can take anywhere from 6 to 8 months depending on the alignment of the planets. The spacecraft must be designed to withstand the harsh conditions of space travel, including radiation exposure, microgravity, and extreme temperatures. The astronauts must also be trained to handle the physical and psychological demands of long-duration spaceflight. Once the spacecraft reaches Mars, the pilot must navigate through the planet's thin atmosphere and land safely on the surface. This requires precise control of the spacecraft's speed, altitude, and trajectory. The pilot must also be prepared to deal with unexpected challenges such as equipment malfunctions or communication failures. Despite these challenges, piloting humans to Mars has the potential to advance our understanding of the universe and our place in it. It could help us discover new resources, develop new technologies, and inspire future generations of scientists and explorers. On their way to Mars, crew members will have to eat and sleep in a confined space. According to a NASA-funded study, the crew could be put into a deep sleep, or torpor, during the long 6-month journey to Mars. This would significantly reduce the number of supplies and infrastructure needed to support the long space journey, from food to onboard living space. The study predicts that putting a spacecraft's crew into torpor would cut the mission requirements from 400 tons to 220 tons of equipment and supplies. During the mission, crew members will live and work inside a 1,700 square foot, 158 square meter space to simulate living on Mars. They will eat freeze-dried food, use a composting toilet, take 30-second showers to conserve water, and never step outside without a spacesuit and helmet. The focus for the first experiment is nutrition, but researchers will also monitor how well the crew sleeps. It is also suggested that astronauts could sleep in shifts, with each astronaut in torpor for about 2 weeks and then conscious for 2 days, ensuring that one crew member is always awake during the mission. While in stasis state, astronauts would be fed intravenously with an aqueous solution of carbohydrates, amino acids, dextrose, and lipids. During this trip to Mars, the spacecraft will travel about 300 million miles. The journey will begin after launch and is called the cruise phase. Engineers have several opportunities to adjust the spacecraft's flight path to ensure its speed and direction are best for arrival at Jezero crater on Mars. The spacecraft departs Earth at a speed of about 24,600 miles per hour, about 39,600 kilometers per hour. During the journey, engineers will monitor and calibrate the spacecraft and its onboard subsystems and instruments. They will also conduct navigation activities, such as trajectory correction maneuvers, to determine and correct the flight path and train navigators before atmospheric entry. The last 3 correction maneuvers are scheduled during approach. Preparing for entry, descent, and landing, EDL, and surface operations is also part of the process, which includes tests of communications, including the communications to be used during EDL. The first astronauts on Mars will have to make an effort to make their new home a comfortable place to live. Colonists will establish protected corridors between land and houses, deploy additional solar panels, and mount greenhouses, settling in the habitat. Before that, astronauts aboard the Orion spacecraft will explore the asteroid in the 2020s, returning to Earth with samples. Please note that a trip to Mars is a complex undertaking that requires careful planning and execution. It involves many challenges such as radiation exposure, isolation, and psychological stress. NASA has been conducting research to address these challenges and ensure the safety of astronauts during long-duration space missions. NASA and SpaceX are working together to develop a communication system that will enable astronauts to communicate with Earth during their journey to Mars and back. The communication system will be based on laser technology, which is faster and more efficient than the current radio frequency communication systems used in space. NASA is also developing a new laser communication system called the Integrated LCRD Low Earth Orbit User Modem and Amplifier Terminal, ILLUMAT, which will be launched in early 2023 in the Dragon trunk of SpaceX's 27th Commercial Resupply Services mission to the International Space Station. This new system will bring laser communications to the orbiting laboratory and empower astronauts living and working there with enhanced data capabilities. It is important to note that the communication system for Mars missions is still being developed, and there are many challenges that need to be overcome before it can be implemented. For example, the distance between Earth and Mars varies depending on their positions in their respective orbits around the Sun, which can make communication difficult. However, NASA and SpaceX are working hard to overcome these challenges and develop a reliable communication system that will enable astronauts to communicate with Earth during their journey to Mars and back. The Integrated LCRD Low Earth Orbit User Modem and Amplifier Terminal, ILLUMAT, is a specialized technology developed by NASA's Goddard Space Flight Center and the Massachusetts Institute of Technology, Lincoln Laboratory, a federally funded research and development center. It is an optical communications payload that will provide astronauts and experiments aboard the International Space Station with enhanced data capabilities. ILLUMAT will be mounted to the space station's Japanese Experiment Module Exposed Facility, GEM-F, and will leverage optical communications to send high-resolution information from the space station to NASA's first optical relay, the Laser Communications Relay Demonstration, LCRD, located in geosynchronous orbit, GEO. After collecting data, ILLUMAT will send the information to LCRD over 1.244 gigabits per second optical links. This data will then be beamed down to optical ground stations in Haleakala, Hawaii, and Table Mountain, California, which were chosen for their minimal cloud coverage, as clouds can disrupt optical signals. The terminal is targeted to launch in 2023 on a SpaceX mission. It is the size of a standard refrigerator and utilizes multiple laser sources housed within the modem module to create the specific wavelengths required to initialize communication and then perform high-speed data transfer. Astronauts on Mars would communicate with Earth through the following ways. Most data traveling back to Earth must first be sent to the Mars orbiter's overhead, which then transmit the data tens of millions of miles through interplanetary space to radio antennas on Earth. Lasers can increase the data rate from Mars by about 10 times what you get from radio. Some of the Perseverance images and data transmitted to Earth via the Mars Relay Network will arrive at NASA's Deep Space Network, DSN. Rovers and landers on the Martian surface beam radio signals up to spacecraft that orbit Mars, which then relay the radio waves to Earth. Radio waves are one of the most common ways that astronauts communicate with Earth while in space. Intercoms and social media are also used. The EDL phase is the most intense part of the mission and lasts about 7 minutes. The spacecraft carrying astronauts would probably be significantly heavier than the various rovers that have landed on the Martian terrain to date, so slowing them down successfully will be an issue. The EDL process begins when the spacecraft reaches the top of the Martian atmosphere, traveling nearly 12,500 miles per hour, 20,000 kilometers per hour. The spacecraft then sheds its cruise stage, which houses solar panels, radios, and fuel tanks used during its flight to Mars. Only the protective aeroshell, with rover and descent stage inside, makes the trip to the surface. The spacecraft then uses small thrusters on the back shell to reorient itself and make sure the heat shield is facing forward for what comes next. The spacecraft then slows down using the drag generated by its motion in the Martian atmosphere. The spacecraft then deploys a supersonic parachute to slow down further. Finally, with a large lander, retro rockets and landing legs are used to touch down at about 6 miles an hour.
Thank you, everybody. Thank you. Thank you so much. Thank you, everybody. Please have a seat. Thank you.
The astronauts will need to adapt to Mars gravity, which is about 40% that on Earth's surface, after a lengthy trek in microgravity. The first human landing on Mars is a significant milestone in space exploration. It is likely that there will be extensive coverage of this historic event. The media will go nuts across the world and may report on various aspects of the mission, such as how it was planned and executed, what challenges were faced and overcome, and what scientific discoveries were made. There may also be interviews with the astronauts who made the journey and with scientists who worked on the project. It is also possible that there will be discussions about what this achievement means for humanity as a whole. Landing humans on Mars would be a significant milestone in space exploration and could pave the way for future missions to other planets in our solar system and beyond. Astronauts will establish a permanent settlement on Mars. Org article, a comprehensive blueprint has been created for the settlement of Mars. Another possibility is that humans could continue to explore Mars and conduct scientific research on the planet. NASA's Perseverance rover is currently exploring Mars and collecting data that could help scientists better understand the planet. It is also possible that humans could use Mars as a launching point for further exploration of the solar system. According to an Inverse article, NASA and the European Space Agency are planning missions to Venus and Mars by 2033. These missions will culminate with the creation of a Mars surface habitat that will enable future missions and research. In conclusion, there are many exciting possibilities for what humans could do next after landing on Mars. The future of space exploration is full of potential, and it will be interesting to see what happens next. After landing on Mars, astronauts will experience a range of physical and psychological changes. The most immediate change will be the reduced gravity on Mars, which is about 38% of Earth's gravity. This will cause the astronauts to feel lighter and more agile than they would on Earth. The landing process itself can be quite jarring, with the capsule hitting the ground at high speeds. Astronaut Soichi Noguchi described the experience as good and bad, but all I feel is, now we are back to reality, and sometimes reality bites. Once they are on the surface, astronauts will need to adjust to the thin atmosphere on Mars, which is only about 1% as dense as Earth's atmosphere. This means that they will need to wear pressurized suits in order to breathe and protect themselves from the harsh environment. Astronauts may also experience a range of psychological effects after landing on Mars. They may feel isolated and homesick due to the long duration of space travel and the distance from Earth. Additionally, they may experience a phenomenon known as the overview effect, which is a profound sense of awe and interconnectedness that some astronauts feel when looking at Earth from space. Overall, landing on Mars will be a challenging and transformative experience for astronauts, both physically and mentally. A day on Mars, also known as a sol, is slightly longer than a day on Earth. It takes Mars 24 hours, 39 minutes, and 35 seconds to complete a solar day, which is the time between two consecutive sunrises or sunsets. A sidereal day, which is the time it takes Mars to rotate once on its axis relative to the stars, is 24 hours, 37 minutes, and 22 seconds. Mars has a day and night cycle similar to Earth and rotates on its axis once every 24.6 hours. Mars has a seasonal cycle similar to Earth's because of its tilted axis. The planet's axial tilt is about 25 degrees, which is similar to Earth's axial tilt of 23.5 degrees. This means that Mars experiences seasons like Earth does. As for the nights on Mars, they are very cold due to the planet's thin atmosphere and lack of heat-trapping greenhouse gases. The average temperature on Mars is about -80 degrees Fahrenheit, -62 degrees Celsius. Throughout the 20th century, multiple proposals have been made for the crewed exploration of Mars. These include the famed Mars Project by Wernher von Braun, the Mars Direct Mission Architecture by Robert Zubrin and David Baker, NASA's Mars Design Reference Mission Studies, and SpaceX's Mars and Beyond plan. By 2033, two space agencies, NASA and the CNSA, plan to commence sending crews and payloads to the Red Planet. These and other space agencies envision building bases there that could eventually lead to permanent settlements and the first Martians. This presents several major challenges, not the least of which have to do with exposure to radiation, extreme temperatures, dust storms, low atmospheric pressure, and lower gravity. However, with the right strategies and technology, these challenges could be turned into opportunities for growth and innovation. In a recent paper, a Leiden University researcher offers a roadmap for a Martian settlement that leverages recent advancements in technology and offers solutions that emphasize sustainability, efficiency, and the well-being of the settlers. The proposal comes from Florian Newcart, an assistant professor with the Leiden Institute of Advanced Computer Science, LIACS, at Leiden University and a board member of the Swiss quantum technology developer Terra Quantum AG. The preprint of his paper, Towards Sustainable Horizons, a comprehensive blueprint for Mars colonization, was recently posted to the archive preprint server and is currently being reviewed for publication by Elsevier. Evolution of a plan beyond exploration, many proposals have been made since the dawn of the space age to transform Mars into a second home for humanity. Some of these proposals have involved geological engineering, aka terraforming, to make Mars habitable for terrestrial organisms. What's more, the history of proposals has reflected the history of exploration and our growing understanding of the Red Planet. Other factors include technological advancement, scientific discoveries, and socio-economic and political developments. As Newekart explained via email, the earliest ideas were largely embodied in science fiction. Examples include H.G. Wells' War of the Worlds, Edgar Rice Burroughs' Barsoom series, Ray Bradbury's The Martian Chronicles, Arthur C. Clarke's The Sands of Mars, and Robert A. Heinlein's Red Planet and Stranger in a Strange Land. These books depicted Mars with limited scientific accuracy and reflected popular perceptions about Mars at the time. This included Schiaparelli's maps, that included Martian, canals, and Percival Lowell's speculations about a Martian civilization. They were also influenced by political events on Earth, which contributed to feelings of xenophobia, the decline of civilization, and environmental concerns. However, things began to change with the dawn of the space age, where robotic exploration dispelled old myths and led to major discoveries about Mars's past and present. As Newekart explained, the latter part of the 20th century and early 21st century marked the deployment of various robotic missions to Mars, such as the Viking program, rovers like Spirit, Opportunity, and Curiosity, and orbiters like Mars Odyssey. These missions provided invaluable Martian geology, climate, and potential habitability data. Post-2000, discussions about Mars have increasingly leaned towards human exploration and settlement. The strategies entailed harnessing in situ resources, understanding potential health implications for astronauts, and developing the necessary technologies to support human life on Mars. The recent era has also seen the burgeoning involvement of private entities, such as SpaceX, in Martian settlement plans. Elon Musk's vision of making humanity a multi-planetary species, with particular emphasis on establishing a city on Mars, has introduced new perspectives and significant investment in Mars-related technologies. Today, more space agencies are contributing to the exploration of Mars than ever before. Whereas the 20th century saw only NASA and the Soviet Union send missions to the Red Planet, the past 2 decades have seen new missions sent by the European Union, China, India, and the United Arab Emirates. This has contributed to a growing recognition that Martian settlement will likely be an international endeavor based on partnerships and cooperation rather than competition. And as Newekit adds, our growing sense of climate awareness has had a noticeable effect on planning. Recent plans have emphasized sustainability more, ensuring that Martian settlements are self-sufficient and have minimal reliance on resupply from Earth. This includes considering closed-loop life support systems, in-situ resource utilization, and psychological sustainability for inhabitants. Martian settlement plans have evolved through these stages from speculative and primarily science fiction-based ideas to more concrete, scientifically informed, and technologically feasible concepts rooted in actual data and evolving technological capabilities. As we progress, plans continue to become more refined, pragmatic, and inclusive of various scientific, social, and ethical considerations. The soil on Mars is called regolith and is composed of fine dust and rocks that cover the planet's surface. Unlike soil on Earth, regolith does not contain organic matter. The properties of regolith, such as its toxicity due to the presence of perchlorates, can differ from soil. Martian soil is slightly alkaline and contains vital nutrients such as magnesium, sodium, potassium, and chloride. These nutrients are ingredients for living organisms to grow on Earth. Research suggests that Martian soil has some of the nutrients plants need to grow and survive. Therefore, it is possible to grow crops on Mars. However, Martian soil is also known to contain a high concentration of toxic molecules called perchlorates, which can kill microorganisms and harm human health. These molecules will need to be removed before the soil can be used to grow food crops on Mars. In summary, Martian soil has the potential to support plant growth, but it needs to be treated before it can be used for agriculture. According to a study conducted by NASA Jet Propulsion Laboratory scientists, while Martian soil contains no organic matter, conditions beneath the surface may once have been more favorable to the existence of life on the Red Planet. However, the entire Martian surface is apparently sterile at present due to a process called photocatalytic oxidation, which destroys any organic molecules by free oxygen radicals. The soil on Mars contains a substance called iron oxide, which gives the planet its red color. The Martian surface is covered with deep canyons and huge, inactive volcanoes. The soil on Mars also contains sulfur, nitrogen, oxygen, phosphorus and carbon, key ingredients necessary for life, in the powder sample drilled from the sheepbed, mudstone in Yellowknife Bay. It is worth noting that no samples of Martian soil have been returned to Earth yet. Seeds planted in lunar soil readily germinate when given water and nutrients, but Martian soil shows no signs of biological activity when similarly treated. Mars Defense Force, MDF, which was established to protect 5 civilian settlements on Mars. The MDF was not sponsored by any government or governmental agency, but by an international group comprised of the United States, Germany, Russia and China. The MDF aimed to research the viability of establishing a human civilization in space should a cataclysm occur on Earth. The combined 2 service Mars programs, Army and Air Force, volunteer force of over 3,000 dedicated and skilled amateur radio operators provide the backbone of the Mars program. The Mars Defense Force, MDF, is a branch of the U.S. Marine Corps, according to. The MDF is responsible for protecting 5 civilian settlements on Mars that already exist. The MDF is part of the Earth Defense Force, EDF, which is a secret government organization that aims to protect humanity from extraterrestrial attacks. There are several benefits of exploring Mars. Scientific exploration. Mars is a valuable place for exploration because it can be reached in 6.5 months, is a major opportunity for scientific exploration, and has been mapped and studied for several decades. The recent launch of the Mars rover Perseverance is the latest US space mission seeking to understand our solar system. Its expected arrival at the Red Planet in mid-February 2021 has a number of objectives linked to science and innovation. The rover is equipped with sophisticated instruments designed to search for the remains of ancient microbial life, take pictures and videos of rocks, drill for soil and rock samples, and use a small helicopter to fly around the Jezero crater landing spot. Understanding the origins and ubiquity of life, the site where Perseverance is expected to land is the place where experts believe 3.5 billion years ago held a lake filled with water and flowing rivers. It is an ideal place to search for the residues of microbial life, test new technologies, and lay the groundwork for human exploration down the road. The mission plans to investigate whether microbial life existed on Mars billions of years ago and therefore that life is not unique to planet Earth. Preparing for future human exploration, the scientific reasons for going to Mars can be summarized by the search for life, understanding the surface and the planet's evolution, and preparing for future human exploration. Searching for life on Mars can help us understand whether life existed elsewhere in the universe beyond Earth, which is a fundamental question of humankind. Distribution of Earth's population. Colonizing Mars would help to distribute the Earth's population, which is projected to reach 9.8 billion by 2050 and 11.2 billion by 2100, and improve the chances of humankind's survival in case Earth becomes unsustainable. Extraction of additional natural resources. Colonizing Mars would enable the extraction of additional natural resources, such as fossil fuels, and the generation of food, oxygen, and materials on site. Mining on Mars could also help us find ores that would be useful to potential colonists. However, it is important to note that mining on Mars is still in its infancy and there are many challenges that need to be overcome before it can become a reality. Robotics may be the answer, but even terrestrial mining systems are not yet fully autonomous, so new technologies will need to be developed. Collaborative approaches between companies and governments, and between global governments, are also vitally important. Sophisticated, advanced propulsion systems will be needed to get spacecraft to Mars, land humans on the planet, get him back off Mars, and return him to Earth. When it comes time to take off from the Martian surface, the Mars Ascent Vehicle, MAV, will need 33 tons of propellant to break free of the red planet's gravity, push through its atmosphere, and safely ferry the astronauts and their scientific cargo into orbit, where they can rendezvous and dock with their Earth return vehicle. NASA and ESA are working to plan ways to bring the first samples of Mars rocks and soil back to Earth for detailed study. The Mars Sample Return is a multi-mission campaign designed to retrieve the cores Perseverance will collect over the next several years. Currently in the concept design and technology development phase, the campaign is one of the most ambitious endeavors in spaceflight history, involving multiple spacecraft, multiple launches, and dozens of government agencies. It is important to note that returning humans from Mars is still a work in progress. NASA has crafted 4 potential pathways to Mars human missions, of which 3 included a Mars sample return as a prerequisite to human landing. The radio signals back to Earth would take not a second or so as with Armstrong, but 3 to 20 minutes depending on the alignment of Earth and Mars. The first astronauts to return from Mars would be the pioneers of interplanetary travel. The journey back to Earth would be a long and arduous one, taking several months to complete. The astronauts would have to endure the physical and psychological challenges of living in a confined space for an extended period of time, with limited resources and no access to medical facilities. Upon their return, the astronauts would be celebrated as heroes and trailblazers, having accomplished one of the greatest feats in human history. They would be studied extensively by scientists and researchers to learn more about the effects of long-term space travel on the human body and mind. It's worth noting that no human has ever traveled to Mars yet, let alone returned from it. However, NASA is planning a manned mission to Mars in the 2030s. We can only imagine what it would be like for the first astronauts to return from such a historic mission. Piloting a spacecraft from Mars to Earth is a complex and challenging task. The difficulty arises from 3 main factors: the planet's gravity, Mars' atmosphere, and the distance between the 2 planets. The gravity of Mars is only about 38% of Earth's gravity, which means that a spacecraft leaving Mars needs to be accelerated to a much higher speed than it would need to be on Earth. The distance between Mars and Earth varies depending on their relative positions in their orbits around the Sun. At their closest approach, Mars and Earth are about 34 million miles apart. At their farthest, they are about 250 million miles apart. This distance makes it difficult to communicate with spacecraft in real time, so engineers must pre-program the spacecraft with instructions for its journey back to Earth.